In this video, we're going to work through this problem. At a certain college, 58% of employees can carry dependent family members on their health insurance plans. Currently, there are 225 employees working for the college. A random sample of 40 employees is selected. Complete parts A through C below. So, what is the probability that less than 62% of the sample carries dependent family members on their health insurance plans? So, if you click on question help just to see the formula, we are looking at a proportion here because it's giving you asking you to find the probability of a percentage of the sample. So first we need to calculate the standard error of the proportion. So I have already put the formula up here, and that is going to be step 1. N is 40. That was our sample size. Uppercase N was 225. That is our population size. This was given to you in the problem. 40 employees. There are currently 225 employees working for the college, and we got a random sample of 40. Okay, then the population proportion, it gives it to you at the very beginning. 58% of employees carry dependent family members on their health insurance plans. So that's the population proportion. We are trying to find the probability that less than 62%. So 62% is our sample proportion. So now we can calculate the standard error of a proportion. So P, all we're going to do is plug in. P is 0.58 times 1 minus P. So 1 minus 0.58 over N, which is 40. And then times the population size minus the sample size over the population size minus 1. So let's simplify this. We're going to do the square root of 0.58 times 0.42 over 40, and then 185 over 224. So we're going to put all of that in our calculator before we round. Okay, so if we look at our example, once you get the standard error of the proportion, you're going to round it to 4 decimal places. So you should have gotten 0.0709. Okay, once you have gotten that, now you need to get the z-scores to look up the probability. So the z-score of a proportion is equal to the sample proportion minus the population proportion divided by the standard error of the proportion, which is what we just got, 0.0709. So that is going to be 0.04 divided by 0.0709. Okay, so once you have gotten that, let's look at our steps. So there's the formula. Our z-score, we're going to round to 2 decimal places. So that is going to be 0.56. Now we want the probability that z is less than 0.56. Okay, now for this last step, you're going to have to, I'm going to go through here and so I can show you that it says while you could use the table to find the area, in this exercise use technology. So we're going to open StatCrunch. Let me make this bigger real quick. Okay, so you're going to go to Stat and I believe it is Stat Calculators and Normal. And then what you want to do is we want the probability that X is, let me look what we want, less than 0.56. Okay, and that would be 0.7122. Let me double check that. Okay, going back, we want to round the Z value to 0.5. We want to round it to 4 decimal places. And even though we want it to be less than 0.5642, and there's not an option to put in less, there's two things you could do here. You could put in greater than or equal to 0.5642 and then subtract that, which would be 1 minus, subtract out this area because we want everything, we want it to be less than that. So we could subtract out minus 0.2863 and that would give us 0.7137, or you can just put in less than or equal to 0.5642, and even though we want less than this number, the rounding is going to put it at 0.7137, which is acceptable for this question because you can have anything close to 0.7136 plus 0.0007 would be 0.7143. So even though we didn't put in less than, it will still give us a close enough answer. Okay. All right. So for the next one, answer the question, but this time we're going to use 100 and 150. Answer the question in Part A using sample sizes of 100 and 150. And what is the probability that less than 62% of the sample carries the dependent family members? So let's look at that. I'm just showing you. So here it says Part B, answer the question using sample sizes of 100 and 150, rounding to 4 decimal places. Okay, so let's do that one first. And then I think it wants us to calculate it with 100, then calculate it with 150. So I'm going to pause it and put my information in. Okay, so I have plugged it into the formula, and basically the only thing that is going to change is n in the standard error of proportion formula. So once you calculate that, the standard error should be 0.0369, and then your z value for your proportion is 1.084. So you can pause it and check your work. And then we're going to put in 1.084. Let me make sure. 1.0840. So we get 0.8608. Let's check that. Okay? All right. Find the probability that the sample size is 150. So you're going to do the same thing except change 100 to 100. Okay, and then for the sample size of 150, all we need to change is 150 for n and plug it in, and you will get 0.0233 for the standard error of the proportion and 1.7167 for the z value. Now you can work this, pause the video, work it out, and make sure you get those two numbers. Then once you can, plug it in into, remember, you go to stat, calculators, and then normal, and put in 1.7167, and you get 0.9569. Well, no, 0.9570. All right, explain the differences in these probabilities. So increasing the sample size, okay? Increasing the sample size, if we look at this, you can see that the z values, let me pause it for a second. Okay, so if you increase the sample size, the larger the sample size is, the more representative it will be of the population. So your standard error is going to go down. And then what that does is, the bigger the sample size, it's going to increase the probability that the proportion will be closer to the population proportion. Okay, now it says answer the question in part A without the finite correction factor. So taking out the finite correction factor, that means you're going to take out this part of the formula. So I'm going to pause it and work it that way. Okay, so when you plug it in without the population correction factor, this is what you'll get for your standard error proportion, and this is what you'll get for z. So pause it, check it, and make sure you can work it and get the same answer. And then plug it in into the normal calculator, and you should get 0.6960. And okay, I got in a hurry on the last one. I read it too fast. But when you're calculating the standard error without the population correction factor, the best thing to do is look at your standard error when you had the finite correction factor. And since I erased it, I just need to look at it again. 225 minus 40 over 225 minus 1. So let's compare it. Okay, so you can see here that without it, this is larger. Okay, so the standard error is overestimated. And that makes the probability be underestimated because the probability is lower. See, it's 0.6960 and it's 0.7136 here. So that population correction factor is going to help it, the standard error, be smaller, which is going to make your probability be higher. Let me know if you have any more questions.